kind of looking like my goal of 2 videos might not be achieved, but I'm going to try it here. Like I said, a little bit longer note session today just because there's more of BP3. So welcome back to video 2 on BP3, Unit 1, Motion and Forces. We're starting to talk about these net force diagrams before we left, and I got to the point on this last bullet point where if multiple forces are represented, forces in the same direction are going to add together, and forces in opposite directions are going to subtract. Let's see what that looks like. So here's a force diagram without numbers added to it yet. So the top one is 2 forces going in the same direction. So maybe envision with yourself 2 people pushing on something, on a boulder or on a fridge. It's going to add together. Whereas if we have subtracting forces, it's going to kind of be like more 2 people pushing from opposite sides, or even tug of war, if you want to think about it, if they're pulling in opposite directions. You would subtract those forces to get the net force. Net force is the total. Net's another way of saying total force. So on these ones, you can do it on your own. Pause the video right now if you want to do it on your own, but I'll walk through it really quick. The first one, the first object, the top one, we got 2 5-Newton forces acting in the vertical direction. So there's no movement in the vertical direction, or no change in movement in the vertical direction. But you have a 15 Newton and a 20 Newton heading to the right. Those add together for 35 Newtons of force. This object would be accelerating to the right. Bottom object, nothing acting in the vertical direction, so there's no change in motion in the vertical direction. But there's a 20 heading to the right, and a 30 heading to the right, and a 15 heading to the left. 20 plus 30 is 50 because they're heading in the same direction. Minus 15 gives me 35 newtons to the right for the second object. Both of them actually have a net force of 30 newtons heading to the right. They would be accelerating to the right. So balance force, I was mentioning in my previous example, balance force is that the net force is equal to 0. So the 2 forces are canceling out. You can imagine a perfectly tied tug of war. If you have a cup of water sitting in front of you, it might be that, or even yourself, that's just sitting there. There is no motion. The only way you can have no motion is if everything's balanced, or it's moving at a constant velocity. So you can imagine like the moon or a satellite traveling around Earth moving at a constant velocity. Net force of 0. Balance forces do not always mean that they're at rest. I just mentioned like satellites and the moon would qualify. It means that it's maintaining a constant speed. We usually think of that constant speed as being 0. But if you set the cruise control on your car, highly recommend cruise control, by the way. I get annoyed with people that don't use it, to 70 miles per hour, and you're traveling down the road at a constant 70 miles per hour, then the force of your engine is counteracting the force of friction, and you have a net force of 0 to stay at 70 miles per hour. Unbalanced means that the net force is anything other than 0. So the net force is not at 0, and the object is accelerating. So your car getting up onto the highway, you're hitting that gas pedal and your car is getting faster. You're accelerating, or you're hitting the brakes to come off of the highway or to get to a stop sign, and your car is slowing down. That is an unbalanced force, and any unbalanced force is causing you to change your velocity. Some common forces, if we're talking about forces, and this is physical science where we want to talk about common stuff, basically it's friction and gravity. Really, there's other forces out there, don't get me wrong, but in our everyday life, which is what physical science is supposed to be, we're really talking about friction and gravity. Friction is a force that opposes the motion of any objects that are in contact. So if they're like in contact with a surface and rubbing against each other, or if they're colliding with each other, that's friction. Friction can be broken down into static, rolling, and sliding. Not needed for the test, but kind of just as you're thinking about types of friction with like tires versus trying to slide your hand along the floor versus maybe falling through the air and experiencing air resistance, which is a type of friction. Gravity looks like my last slide for this one, so it will be 3 videos. Gravity is an attractive force that pulls all objects that have mass together. There's some fancy equations out there for it. Take physics if you want to know those. But basically, gravity just pulls any 2 objects that have mass towards each other. Here on Earth, that creates a constant acceleration of 9.8 meters per second per second. I'll finish this one up on the next video, hopefully our last one.